In this module, we're going to talk about the profession of modeling and simulation. This is very big picture stuff, but it's important because while you might think you know what modeling and simulation actually is, there's something to be said for when you have a degree or certificate or whatever it is you're going to have in modeling and simulation. What does that mean to people? What they say, okay, well you've got a moves degree. Okay, so you're a modeling and simulation guy. What did that just communicate to them? What skill set do you have that they wouldn't expect, like maybe from their IT guy or their ops analysis guy or something like that? What makes you special? So let's unpack that, take a look at what it means. So the topics for this module are, we're going to look at M&S as a discipline. And I want to actually look at specifically at that word discipline, because this is a university and that word means something very specific, so we're going to talk about it. We're going to talk about what modeling and simulation professionals do, and then we're going to look at how do we fit into this bigger picture of training and education and operations and all these sorts of things and analysis, all the stuff that we do. How do we fit into that? And then what do others expect of us as modeling and simulation professionals? So the first question we're going to ask is, modeling and simulation a discipline? So first we've got to say, what do we mean by when we say discipline? As I said, universities mean something very specific when they say that. Real good example is, my background is computer science. Computer science has not been a quote-unquote discipline very long. We grew out of applied mathematics. Before there were computer science departments, if you wanted to study computers, remember computers have been around since the 40s. Computer science departments didn't start popping up until maybe the 60s. Or 70s. First PhD in computer science wasn't until 70s. So it really wasn't a discipline, but there were still people studying computers, of course. Look, they got better. People were developing these skills. They were inventing the things that you take for granted today. So where was this coming from? And it evolved into a discipline. And what we mean by that is when we talk about a discipline, we talk about knowledge or wisdom associated with one academic field of study that incorporates specific types of knowledge and skills, expertise, problems and challenges, studies and inquiry, approaches and methodology, and research areas. Specifically look at, not just the knowledge and skills, because you could look at M&S and you could say everything, if you made a list of all the knowledge and skills you need to have to be an M&S professional, I'll bet you could find another discipline that has just about every single one of them, almost. Where it really gets interesting is when you get down to like approaches and methodologies. So you think about what it is we do as M&S professionals. If somebody were to talk to you about an experiment that they ran on a training system, determine whether or not this particular feature of the training system was useful and had a positive training impact, that wouldn't surprise you. You've seen those before. That's a methodology. It's it's a recipe for doing research that you're completely comfortable with because you're part of this discipline. If somebody were to do something in analysis, you'd be comfortable with that. Somebody were to talk about the use of M&S in acquisition, you'd be comfortable with that. If I were to bring a social scientist in here, an anthropologist who come in here and talk to you about what he does for a living, you would think he was from Mars. You'd say, what? I've never heard of that. You observe people, you take notes about what people's behavior, what is that? That's research? Well, it actually is definitely research. And it's very well-refined research. It's research that's much older than the stuff you're doing. But it's different because it's in a different discipline. The interesting thing about M&S is because we're so broad and to touch so many different other disciplines, we kind of need to know a little bit about all of them. So I'm going to leave it at this point on whether or not M&S is a discipline for our next couple of slides, but I wanted to make sure you understood what we meant when we talk about a discipline. There's some uniqueness to it that's different. It may be the convergence of other things, but it still has a uniqueness to it. So let's do this first. Argument one is that M&S is not a discipline. What's that argument? We'll say what you will often hear is that it's not a discipline because it's really the synthesis of a bunch of other fields: computing sciences, mathematics, information sciences, ops research, all these other things. It's all those things. If you were to cut M&S apart, you can totally cover it by all those other disciplines. Just the merging of disciplines does not constitute a new discipline. Okay, I'll buy that. You'll also hear that M&S is really an artifact. It's just a tool of these other disciplines for the purpose of study and exploration. It's not a thing in and of itself. It's just a tool. It's just like a hammer was developed by carpenters to pound nails. M&S was developed by analysts to study problems that they couldn't study some other way. All members of the M&S community are really from one of these other disciplines anyway. And they're just applying their skills to this artifact. So my example is Galileo, and everybody knows who Galileo was, studied optics to help him study astronomy. In fact, many people regard Galileo as the father of optics. Invented much of what we know about optical engineering today. But he wasn't doing it for optics. He was doing it because he was an astronomer. So what was his field of study? Was it astronomy or optics? I'll argue that it was astronomy, but he had to have optics to do it. So, of course, the other argument is that M&S is a new discipline, that it does have unique knowledge, tools, methods, expertise, challenges that are not in other disciplines. And what are some of those? Could we make an argument that things like agent technologies, agent models, interoperability, the way we talk about interoperability, VV&A, right? Who else talks about VV&A? Maybe some aspects of human interaction. What other things can you think of that we do in M&S that you'd really have a hard time saying, no, those are in other fields? And M&S is an artifact or a tool of these other disciplines for the purpose of study and exploration, but I'll argue that the artifact itself has reached a level of interest to be considered a discipline of its own. And my example here is, same one. So Galileo invents optics. He starts figuring out how to grind glass in different shapes and use them as lenses so that he can bring the stars closer to him to study. He's still an astronomer, but now there's this optics thing. And every year he keeps trying to make his optics a little better, trying to figure out better ways of making it clearer, making it amplifying the magnification, making it lighter so he can take it different places. He's improving it every year. And eventually somebody comes along and says, you know, I don't really care about astronomy. This optics thing is really interesting. Because think about all the other things I can do with optics. I'll argue that that's exactly what happened with M&S. Initially, it was just a tool. Oceanographers and military analysts and manufacturers, all these folks were using M&S as a tool to solve their problems. And then we come along and say, you know what? The tool itself is interesting. It's a discipline. So another point I want to make here with regard to simulation is how it has impacted the scientific method. And you remember how the scientific method works, right? You have a theory. That theory generates hypotheses that will prove or disprove your theory. The hypothesis then lends itself to an experiment that controls variables, independent and dependent. You collect your data. You then verify the truth or not truth of your hypothesis, which you may then, depending on how things go with your experiment, it may be that you have to fix your experiment and run it again because you didn't control things properly. It may be that you have to alter your hypothesis because it wasn't quite right. It may be that you have to go all the way back and alter your theory. But that's the scientific method, and we are able to do this because of the way the method controls conditions such that we know where variability comes from. Extraordinarily powerful. Hopefully it's one of the things that you will definitely walk away from your program knowing. But then simulation comes along, and this gets really interesting. All of a sudden there's all these things that we want to study that don't lend themselves to the real world. I want to study, you know, some human phenomena that's involved with crashing helicopters. Well, nobody's going to give me a bunch of helicopters to crash to figure it out. I'm going to have to simulate that, right? It could be something even a lot more benign than that. I just want to fly helicopters. Nobody's going to give me hours of flight time in helicopters to study my phenomena. Or I need a platoon of soldiers to study this. Make the long list of things that you will never, ever get access to the real world to do. I got to simulate those things. And yet, think about this. the result that I want to draw from my experiment, I want to apply to the real world. And yet I don't get access to the real world to study it. So I have to use a simulation. So what that brings into the picture is this. I've got to validate that simulation. I've got to know how that simulation is similar and or different from the real world and what impact those differences have on what I can and cannot conclude about my theory and my hypothesis and how they will function in the real world. That's extraordinarily important. So you will see a lot of work over your career where simulation is being used in the scientific method to draw conclusions about the real world, ask really hard questions about the validation of that simulation, and whether or not we know that you can draw those conclusions about the real world based on what was validated and what was not. So what do we do as M&S professionals? Well, we do lots of stuff. We build models, obviously. You've probably built some yourself. Even the most trivial of models. Things you might have just thrown together in Excel are still models. You know how to do that. We build simulations. We put those models into simulations and we study phenomena over time. We know a lot about training. We know about training schedules. We know about learning theory. We know about all that stuff. We do a lot of exercise support. Our Army FA-57s do a ton of that stuff. They're asked to put together whole exercises, figure out what are we going to measure, how are we going to control the exercise, how are we going to make sure that we hit certain learning points in an exercise. They do all that stuff. Ops analysis. We do a lot of ops analysis, not so much the equation optimization side of it, but the simulation side of it we do a lot of. We look at trade-off analysis, particularly in acquisition. I want to use a simulation to determine whether this airplane wing should look this way or this way, or the ballistic characteristics of this weapon should look like A or B. Well, we're not going to go to full manufacturing or prototyping for each of those to test them out. Before we ever go to live fire, we want to use simulation. It's actually interesting that the live fire test and evaluation community is one of the biggest advocates for modeling and simulation because they have to use it. It's an important tool for them. What about procurement, right? You got to know how to purchase things and how the military system works on how to get things done. You got to know about system development, putting together teams of people, working with contractors. You got to know how to do all that stuff. You got to know about VV&A, validating models. You got to know a lot about strategy and policy. Some of you may find yourself in a job one day where you're writing M&S policy for the entire Department of Defense that's going to impact protocols we use or file formats or big systems that we're going to standardize on. Those are all strategy and policy issues. And then lastly, of course, test and evaluation. We do a ton of that as well across the board, acquisition, analysis, and training. So that's a lot of stuff. This is why, by our very nature, M&S people tend to be very broad and not super deep in any one area. Now, you do a thesis or you do other work. You get deep certainly in things that you're very interested in. But if you're going to call yourself an M&S person, you need to be able to maintain this breadth. So this is when M&S at the DoD level reorganized itself not too many years ago. It used to be that it was just acquisition, analysis, and training. Those were the three legs of the stool they would refer to them as, and they're still there. You see, they're still there, but that wasn't refined enough for a lot of folks, so they threw a few more things in there. So now it's acquisition, analysis, planning, testing, training, and experimentation, and you'll even see another topic come into this, intelligence. So depends on who you talk to. But the theme is that there's different organizations that have a dog in this fight, and then and it changes. Like you'll see, the slide still mentions GIFCOM, which doesn't exist anymore. That's now the J7. Different organizations are interested in these things, and the key is we got to this is a part of our job as M&S professionals in the Department of Defense, is to make sure that those verticals don't stovepipe themselves and start doing their own thing that's counter to what is for the good of the entire thing. That's where those horizontal, cross-cutting tools, data, and services come in. That's why we have things like the AMSO, NMSO, MCMSMO, the Modeling and Simulation Coordination Office for DoD. All those guys exist because they're looking across all these organizations. And real quick, you can see that this is just one that's specific to the Army, but is very similar. And I could put one up for the Air Force, I could put one up for the Marine Corps, I could put one up for the Navy, and it would look very similar. The owners of each of those pieces would be different, but they talk about a lot of the same things. And notice at the bottom of the slide, talk about the goals: interoperability, reuse, and efficiency. You only get that by focusing on the common cross-cutting pieces, but also paying attention to the common cross-cutting pieces aren't what gets the work done. It's those vertical pieces that get the work done. So they have to work together. So how does this fit into the whole training and education piece of what we do at the school anyway? So what we discussed, from what we've discussed so far, which of these activities might happen in your organization or an organization that you've been a part of? Do you build models, simulation software? Do you specify requirements for acquisition? Do you test and validate products? Do you construct learning plans for trainees and students? Or are you responsible for keeping ahead of the curve, which we're going to have a whole module in our course about? There's all this stuff that touches us. Now, maybe one of the most important questions that we could ask is, what do others expect of you as an M&S professional? So you're technical. You're technical. You've studied some technical things, so you must know things about computers, operating systems, network security, devices, displays. You know about that stuff, right? So you just showed up. They say, "Who's the new guy?" And they say, "Oh, he came from the Moves Institute out at NPS. He's got an M&S degree or an M&S certificate." Oh, great. So he can wire all these computers together for us, right? This is part of our communicating with our constituents about what it is that we are that's unique. So we have to make sure we educate others about what it is we do. We are technical, but we know about training. We know about training schedules. We know about learning science. We know about how to measure things. We know about fidelity issues in simulators. You're military, so you know things about SOPs and changing SOPs, variations in SOPs, how to deal with those things in training plans. You're a government professional, so you must know something about procurement practices, financial rules and regs. You know about all that stuff, so I could make you a program manager. You could run this sort of stuff, right? Well, actually, you're all of the above, so you probably know things about writing proposals and strategic planning and securing resources and inventing the future. Right? The future of modeling and simulation isn't necessarily in my hands, it's in yours. So where are we going in the future? This is why all of these are legitimate. When you say you're an M&S professional, people could think all of these things about you, and they're not wrong. So part of what we have to do is educate people even more about what it is we do, but we have to be able to respond to all this. So this is a tough job. You got a lot of things you got to be able to be at least competent in. So that's sort of my snapshot of all the things that may be expected of you as a modeling and simulation professional. I hope it's not too scary because it's a lot. I understand that it's a lot. But frankly, it's one of the reasons why it's such a challenging and fun profession to be in, because almost everything can be your business. So no matter what your interests are, if you're a modeling and simulation professional and you're bored, you're probably not looking very hard for something that's really interesting to do, because just about anything can fall under us in terms of what we might be responsible for or might need to know about. So it's challenging, but it's exciting, and it's got a great future, and we're going to talk a lot more about it.